Today, we're diving deep into the design and structure of one of many representatives of Imperial armored vehicles, Imperial Troop Transport. Fasten your seatbelts and subscribe for more Star Wars insights. Nordy here, and it's time to get started. The K79-S80 Imperial Troop Transport, ITT, though primarily designed as a personnel carrier, features a moderate yet effective armament system tailored for patrol, suppression, and escort duties. Unlike the Trexler 906 Armored Marauder, which was engineered as a dedicated combat vehicle, the ITT's weapons serve a more defensive and deterrent role, allowing it to operate effectively in hostile environments without being a frontline assault vehicle. Its armament consists of two forward-mounted laser cannons and a dorsal twin laser turret, which together provide sufficient firepower to counter light infantry attacks, deter ambushes, and assist in the suppression of enemy positions during Imperial operations. The forward-mounted laser cannons, positioned on either side of the cab, were originally designed as turret-based weapons in early models of the ITT. This allowed for limited independent aiming and fire control, giving the crew greater flexibility in engaging targets while on the move. However, later iterations of the transport featured fixed forward-facing cannons, streamlining the design for simplicity and durability. These cannons, powered by an energy capacitor system, are primarily effective against infantry and light vehicles, providing a directed fire arc that forces the pilot to maneuver the vehicle into position before firing. This system works in conjunction with the ITT's sensor and fire control arrays, which assist in target tracking, but lacks the precision or adaptability of fully turreted weapons. The dorsal twin laser turret is the transport's primary defensive weapon, mounted atop the vehicle for 360-degree rotational coverage. Unlike the forward cannons, which require vehicular positioning to aim, the turret is independently controlled and can engage targets from multiple angles, making it especially useful for deterring ambushes from elevated positions such as rooftops or cliffs. This turret is remotely operated by either the commanding officer or a dedicated gunner, who utilizes the vehicle's fire control computer to track and engage moving targets. The turret is fitted with dual-barrel laser cannons, increasing the rate of fire and ensuring that enemy combatants cannot easily avoid sustained suppression. However, the weapons lack the punch necessary to penetrate heavy armor, making them ineffective against tanks, reinforced fortifications, or shielded targets. The ITT is therefore reliant on supporting vehicles and infantry when facing more formidable resistance. Integrated within the ITT's design is a targeting and fire control system, which aids in aim stabilization, enemy tracking, and firing coordination between weapon stations. The vehicle is equipped with optical and infrared sensors, allowing its crew to detect, identify, and engage hostiles in various environmental conditions, including low-visibility areas such as fog, sandstorms, and night operations. The dorsal turret benefits from a more advanced fire control processor, which compensates for movement and elevation, ensuring that the gunner can maintain accuracy even when engaging fast-moving or distant targets. The forward laser cannons, lacking independent targeting systems, require the pilot to rely on manual maneuvering to achieve firing solutions, making their effectiveness highly dependent on crew skill and battlefield positioning. In convoy operations, multiple ITTs can synchronize their targeting systems, allowing for overlapping fields of fire that create a more cohesive defensive perimeter. Unlike turbolaser-equipped walkers or missile-based ground assault vehicles, the ITT relies entirely on energy-based weaponry, eliminating the need for conventional ammunition storage. Each laser cannon draws power from the vehicle's central energy core, which distributes energy through a series of capacitor banks. These capacitors regulate energy flow, ensuring that the weapons can fire in rapid succession without drawing excessive power from the transport's propulsion or support systems. The turret, being the most frequently used weapon in engagements, is equipped with an overload protection mechanism, which prevents overheating by cycling energy flow between its dual barrels. In extended firefights, the capacitors require periodic cooldowns, meaning sustained fire can only be maintained for a limited duration before a temporary energy redistribution cycle is needed. This constraint makes the ITT less effective in prolonged engagements, necessitating firing discipline and coordinated suppression tactics when used in combat. Though the ITT does not possess integrated secondary weapons, Its troop deployment system functions as an auxiliary means of providing additional firepower. The vehicle's external troop racks, which normally serve to transport stormtroopers or prisoners, can also act as firing platforms. When stormtroopers are positioned in the exterior slots, they can engage targets manually with blaster rifles, effectively turning the ITT into a mobile firing squad. This feature allows for a continuous stream of fire while the vehicle is in motion, making it particularly effective in riot suppression, urban patrols, and convoy escort duties. However, this design exposes the troops to enemy fire, making them vulnerable in open combat. In specialized variants of the ITT, automated sentry droids have been mounted in place of human troops, providing an autonomous defensive capability that does not require manual intervention. These sentry droid configurations are most commonly deployed in high-risk urban centers and Imperial occupation zones, where crowd control and rapid response are priorities. Power management plays a crucial role in maintaining optimal weapon performance, ensuring that energy is efficiently distributed between the transport's propulsion, targeting, and defensive systems. The ITT's onboard power plant is designed to prioritize weapon functionality over speed, meaning that during active engagements, energy is diverted from repulsor lift stabilization to weapon capacitors. This trade-off allows the transport to maintain firepower at the cost of reduced mobility, making it susceptible to flanking maneuvers or heavy ordnance strikes if caught in an unfavorable position. The transport's thermal regulation system, comprised of heat dissipation vents and coolant cycles, prevents excessive energy buildup in the weapon systems. However, under extreme conditions, such as continuous high-output fire or operation in desert environments, thermal efficiency is reduced, requiring additional cool-down periods between volleys. Defensively, the ITT lacks dedicated shielding or armor reinforcement, making it vulnerable to anti-vehicle weaponry, such as missile launchers, ion cannons, and heavy blaster emplacements. Its durasteel plating provides basic resistance against small arms fire, but offers little protection against concentrated attacks. The dorsal turret serves as the primary means of defensive suppression, deterring ambushes from rooftops, sniper positions, or flanking infantry. In urban engagements, the presence of troop firepower from the exterior racks adds an additional layer of reactive defense, albeit at the cost of increased exposure for personnel. While effective in law enforcement and occupation duties, these measures are insufficient for large-scale battlefield operations, meaning the ITT must rely on supporting units when operating in high-threat environments. Though the ITT's weapon systems are not modular in the same way as dedicated combat vehicles, certain modifications have been observed in Imperial security divisions. These include riot control models, which replace the dorsal turret with a crowd dispersal energy projector, as well as cargo variants, which remove exterior troop racks in favor of reinforced storage compartments for military logistics. Additionally, later iterations of the ITT featured improved turret targeting optics and energy efficiency upgrades, enhancing its effectiveness in sustained combat scenarios. Despite these refinements, the transport's core role remained unchanged, prioritizing troop mobility and suppression over direct battlefield engagements. While the K79-S80 Imperial troop transport is not designed for heavy combat, its armament package enables it to fulfill its role in Imperial security operations, counterinsurgency campaigns, and patrol duties. Its weapons serve primarily to deter attacks, provide supporting fire, and maintain control over occupied territories, rather than to engage in prolonged battles. Though limited in firepower, its integration of crew-operated, remote, and troop-based firepower allows it to operate effectively in urban centers, convoys, and planetary garrisons, solidifying its place as a staple of Imperial ground forces across the galaxy. The K79-S80 Imperial Troop Transport (ITT) is equipped with a repulsor lift propulsion system, optimized for urban patrols, planetary garrisons, and convoy operations. Unlike Walker-class vehicles or tracked tanks, which rely on mechanical ground contact, the ITT utilizes low-altitude repulsor lift generators to achieve near-surface levitation, reducing terrain friction and improving energy efficiency in long-distance travel. The repulsor lift system operates by generating anti-gravity fields, counteracting planetary gravity and allowing the vehicle to hover 0.5 to 1 meter above the ground, depending on terrain conditions and power settings. This floating propulsion method enables the ITT to traverse uneven landscapes while minimizing structural stress on its chassis. The vehicle's primary propulsion unit is powered by an SFS-418 repulsor lift drive, a compact but high-output repulsor lift generator manufactured by C&R Fleet Systems. This system provides lift generation and lateral thrust, ensuring smooth movement across urban, desert, and light forest terrains. The repulsor lift engine draws energy from a hypermatter microreactor, which offers an efficient, self-contained power source with minimal fuel requirements. This hypermatter-based reactor is linked to a plasma energy matrix, ensuring a consistent power flow to the repulsor field coils. In contrast to traditional fuel combustion or ion engines, the ITT's repulsor lift drive eliminates the need for exhaust emissions, making it environmentally sealed and capable of operating in vacuum or corrosive atmospheric conditions. Mobility across various terrains is a defining factor in the ITT's battlefield adaptability. The repulsor lift system allows for smooth transit over solid ground, rubble, and shallow water, making it highly effective in urban warfare and perimeter patrols. Unlike tracked vehicles, which suffer from mobility loss in urban rubble, the ITT can traverse collapsed streets, craters, and debris fields with minimal impact on speed. However, the repulsor lift field operates at reduced efficiency over loose sand, swamps, and unstable terrain, as terrain density fluctuations can cause instability in the repulsor lift field calibration, leading to minor altitude fluctuations. In extreme conditions, such as marshlands or soft mud, the ITT compensates with active altitude modulation, adjusting repulsor lift output in real time to maintain stability. However, due to low lift repulsor calibration, it lacks the high altitude clearance of dedicated airborne repulsor craft, limiting its ability to bypass deep trenches or large water bodies. In terms of speed, the ITT operates at a maximum sustained velocity of 90 km per hour, 56 miles per hour, on open terrain, with a combat maneuvering speed of 45 km per hour, 28 miles per hour. This allows for swift deployment of troops while maintaining a steady defensive posture in patrol formations. Acceleration from stationary to full speed occurs within 6.8 seconds, with the repulsor lift drive providing gradual but smooth thrust application. Unlike high-speed repulsor craft, which prioritize aerodynamic efficiency, the ITT's design limits rapid bursts of acceleration to maintain troop stability within its deployment bays. As a result, while capable of moderate speed pursuit, it lacks the instantaneous reaction time of smaller, skirmish-focused vehicles like speeder bikes or scout skiffs. Maneuverability is dictated by the ITT's vector thrust repulsor array, which allows for omnidirectional movement without requiring mechanical turning mechanisms. Unlike wheeled or tracked vehicles, which rely on axial rotation, the ITT utilizes gravitational repulsion vectors to pivot on the spot, achieving a 0-degree turning radius. This feature is especially advantageous in tight urban corridors and fortified checkpoints, where precise maneuvering is required. However, due to its inertia compensation delay, the ITT is less responsive in sharp lateral movements compared to speeder-class repulsor vehicles. In high-speed chases, it requires longer turn arcs, making it less effective in confined areas requiring rapid directional shifts. Additionally, during aggressive maneuvers, the repulsor lift field oscillation can cause instability at higher speeds, necessitating thrust vector modulation to maintain controlled movement. Power distribution is managed through a dual-channel energy regulation system, allocating power between the repulsor lift drive, weapon systems, and onboard electronics. The primary energy core feeds a dedicated propulsion capacitor array, ensuring that thrust output remains consistent even when weapon systems are firing. However, under sustained energy consumption, such as during prolonged repulsor lift hovering at maximum output, the capacitor reserves experience a gradual energy drain, requiring periodic power redistribution cycles. These cycles temporarily reduce repulsor lift efficiency, causing a minor decrease in altitude stability until capacitor recharge is complete. Heat management within the ITT's propulsion system is regulated by a multi-stage cooling array, consisting of thermal dissipators, micro-radiator coils, and energy cycling conduits. Unlike traditional combustion engines, which rely on exhaust venting, the ITT's closed-loop repulsor lift generator prevents heat buildup within the reactor core, by cycling excess thermal energy through radiation baffles along the vehicle's undercarriage. This ensures consistent performance in extreme climates, allowing operation in desert heat, icy tundras, and high-humidity jungle environments without significant power loss. However, in prolonged engagements requiring maximum thrust output, the cooling system experiences progressive thermal saturation, necessitating temporary power modulation to prevent reactor overheating. The ITT's propulsion system is engineered for high operational reliability, requiring minimal maintenance cycles compared to tracked or wheeled vehicles, which suffer from mechanical wear and tear. The repulsor lift coils are magnetically stabilized, reducing the frequency of component realignment and recalibration. However, sustained deployment in high dust or sandstorm conditions leads to magnetization interference, requiring periodic repulsor field recalibration to prevent field drift instability. In extreme cases, repulsor coils may experience particle accumulation, reducing thrust efficiency until a manual servicing cycle is performed. Fuel efficiency is a key advantage of the ITT's hypermatter reactor, allowing for extended operational range without frequent refueling. Unlike fuel-based repulsor craft, which require liquid Tabana or ionized fuel cells, the ITT's reactor functions as a closed-loop energy converter, consuming minimal hypermatter reserves while sustaining high-energy output. However, in the event of a reactor malfunction or energy core breach, the propulsion system lacks an emergency backup drive, rendering the vehicle immobile until field repairs or recovery operations are conducted. The ITT's acoustic and thermal signature is moderately low, with minimal engine noise due to its silent electromagnetic repulsor lift field. Unlike combustion-driven vehicles, which produce engine roar and thermal exhaust, the ITT emits only a low-frequency hum, reducing its audio detection range in occupied cities. However, due to its plasma-based repulsor lift field, the ITT generates a mild infrared signature, making it detectable by thermal imaging sensors in nighttime or low-visibility operations. Tactically, the ITT's propulsion system allows for rapid troop insertion, perimeter control, and urban suppression, making it an ideal vehicle for occupation forces and security detachments. While not built for high-speed warfare, its stable thrust vectoring and precise maneuverability make it a formidable presence in fortified zones and convoy formations, ensuring uninterrupted Imperial enforcement across planetary territories. The K79-S80 Imperial Troop Transport (ITT) is powered by a Cyanar Fleet Systems LH-41 hypermatter microreactor, a compact, high-efficiency power plant designed for sustained operation in urban patrols, planetary garrisons, and convoy escort missions. This reactor functions as the primary energy generation unit, supplying power to the vehicle's repulsor lift propulsion system, onboard weaponry, sensor suite, and auxiliary electronics. Unlike traditional combustion engines or large-scale fusion reactors, the LH-41 utilizes hypermatter annihilation principles, where infinitesimal amounts of hypermatter particles are converted into high-density plasma energy, yielding a high-output, low-maintenance power solution. This method allows for extreme energy efficiency, minimizing fuel requirements while ensuring continuous operational uptime. Energy distribution within the ITT is managed through a trinary phase plasma conduit network, which directs power from the reactor core to primary and secondary systems. The repulsor lift drive is prioritized in the allocation matrix, receiving approximately 65% of total power output under standard operational conditions. The remaining 35% is dynamically split between the laser turret, troop compartment subsystems, and tactical electronics, including targeting computers and encrypted Imperial comm relays. In high-threat scenarios, a combat power modulation system allows for real-time energy redistribution, shifting power between engine output, weapon systems, and defensive functions based on battlefield conditions. This ensures that, when necessary, the vehicle can divert power from propulsion to weapons, maximizing firepower in active engagements while sacrificing mobility. The LH-41 reactor boasts an energy output of approximately 280 megajoules per second, sufficient to sustain prolonged urban operations without requiring reactor cycling downtime. Unlike standard fusion cores, which experience progressive energy degradation over extended deployments, The ITT's hypermatter reactor achieves consistent energy efficiency through an integrated plasma stabilization matrix. This system recycles residual thermal energy, converting waste heat into additional power via thermionic conversion cells embedded within the reactor casing. By reprocessing excess thermal emissions, the ITT minimizes reactor strain, while extending operational longevity without compromising power availability. For redundancy and emergency scenarios, the ITT is equipped with an AUX-13 backup energy capacitor, a high-density energy reserve unit designed to maintain critical systems in the event of a primary reactor shutdown. This capacitor provides approximately 12 minutes of emergency power, sustaining life support, communications, and repulsor lift hover stabilization, while allowing the crew to execute emergency repairs or await extraction. Additionally, a secondary Tibana gas-fed energy converter is integrated as a tertiary backup, capable of generating limited power output for communications and minimal propulsion, though insufficient for full combat engagement. Cooling and heat dissipation within the ITT are managed through a two-stage thermal regulation system, incorporating radiator fins, heat exchangers, and liquid-cooled plasma conduits. The primary heat exchanger, located beneath the vehicle's armored undercarriage, utilizes a circulating coolant medium that absorbs thermal buildup from the reactor core and redistributes it through micronized radiator vents. This design ensures heat dispersal efficiency, preventing energy saturation failures even in prolonged combat scenarios. However, under extreme battlefield conditions, such as continuous high-energy discharge from weapons and propulsion, the cooling system can experience thermal saturation, leading to incremental reactor efficiency loss. To counteract this, the ITT features an emergency thermal purge system, which can vent excess heat through auxiliary dissipation coils, albeit at the cost of temporarily increasing the vehicle's infrared signature, making it more susceptible to enemy heat tracking sensors. The ITT's fuel storage system consists of a reinforced hypermatter containment cell, encased in magnetically stabilized shielding to prevent reactive leaks. Unlike conventional fuel-based power systems, hypermatter containment allows for long-term energy retention with minimal degradation, enabling the ITT to operate for up to 18 standard days without refueling under normal patrol conditions. In high-intensity combat scenarios, reactor consumption increases by 45%, reducing operational time to approximately 11 days before requiring reactor replenishment at a designated Imperial refueling depot. This efficiency makes the ITT highly viable for prolonged planetary deployments, minimizing logistical dependencies while maintaining energy consistency across multiple mission profiles. Durability and maintenance of the ITT's power plant are key factors in its field reliability. The LH-41 reactor features a reinforced Durasteel housing, protecting critical reactor components from battlefield damage. In the event of direct hits to the reactor compartment, the ITT employs an automatic containment lockdown system, sealing compromised plasma conduits to prevent catastrophic reactor breaches. While highly durable, the power plant does require scheduled hypermatter realignment every 2,000 operational hours, ensuring sustained reactor stability and plasma efficiency. Maintenance crews utilize automated diagnostic droids to perform rapid reactor servicing, with full reactor recalibration cycles taking no more than 3 standard hours. Despite its resilience, the ITT's reactor does present vulnerabilities under sustained firepower, particularly from ion-based weaponry, which can cause temporary energy disruptions by destabilizing reactor phase harmonics. To mitigate this, the reactor is integrated with triple-layered ionic shielding, which disperses low to moderate ion interference but remains susceptible to high-output EMP bursts. In scenarios where reactor integrity is compromised, the ITT can execute a controlled reactor shutdown, engaging its backup capacitor system to maintain limited functionality while awaiting repair or extraction. From a modularity perspective, the ITT's power plant is designed for incremental upgrades, allowing for retrofitting with next-generation energy regulators or enhanced plasma stabilization matrices. Over its operational history, earlier iterations of the ITT utilized lower-output fusion cores, which suffered from thermal inefficiencies and higher fuel consumption rates. The transition to hypermatter-based power generation marked a significant technological advancement, increasing energy efficiency by 38%, while reducing overall mass-to-output ratio. Future modifications may incorporate enhanced superconductors or next-gen energy-dampening fields, further improving power efficiency while reducing thermal footprint visibility. In terms of stealth, the ITT's energy signature is moderate, with minimal electromagnetic emissions due to its plasma-stabilized power matrix. Unlike traditional fusion cores, which produce high-output reactor signatures, the hypermatter reactor operates at reduced sensor visibility, making it harder for long-range enemy scanners to detect its presence. However, during maximum power draw, the reactor's plasma oscillation field generates a low-frequency resonance, detectable by advanced sensor suites at medium-range detection thresholds. Comparing the ITT's power system to other ground vehicles, it outperforms conventional tracked tanks and older repulsor lift craft in terms of energy efficiency and operational longevity. While it lacks the raw energy output of heavy armor-class vehicles like ATATS, its reactor is better optimized for sustained urban operations, offering a balance of efficiency, longevity, and adaptability. The ITT's modular power matrix allows for situational energy adjustments, making it ideal for dynamic combat scenarios requiring adaptive power allocation. Tactically, the ITT's power system enables prolonged field deployment, reducing the need for frequent refueling or reactor cycling. The ability to divert energy in combat scenarios provides situational flexibility, ensuring that the vehicle can prioritize mobility, firepower, or defensive endurance as battlefield conditions evolve. However, crews must remain aware of thermal saturation risks in prolonged engagements, as excessive energy redistribution to weapon systems can lead to reactor overheating and performance degradation. Overall, the ITT's LH-41 hypermatter micro-reactor represents a well-balanced power solution, delivering high energy efficiency, battlefield adaptability, and operational longevity, making it a cornerstone of Imperial planetary defense strategies. The K79-S80 Imperial Troop Transport, ITT, is a low-profile, heavily armored repulsor lift vehicle designed for urban pacification, garrison patrols, and planetary convoy escort missions. Its boxy, angular silhouette prioritizes armor density and internal troop capacity over aerodynamic efficiency, making it a durable, high-capacity infantry transport, rather than a high-speed maneuverability platform. The ITT's design reflects the Imperial military doctrine of overwhelming force and intimidation, with a utilitarian, uncompromising structure that maximizes functionality and battlefield survivability. The chassis and frame of the ITT are constructed from reinforced durasteel plating, with an internal skeletal frame composed of high-tensile titanium alloy supports. This combination provides exceptional impact resistance, allowing the vehicle to withstand small arms fire, explosive debris, and environmental stressors without structural failure. The vehicle's centralized weight distribution ensures stability on uneven terrain, with reinforced repulsor lift mounting struts integrated into the lower frame to maintain balance and structural integrity. The hull is modular, allowing for rapid repair and armor panel replacement, while the underbelly features reinforced plating to mitigate the effects of anti-vehicle mines and concussion blasts. The propulsion and locomotion design is centered around a series of high-efficiency repulsor lift generators, positioned along the vehicle's underside and rear stabilizers. These repulsor lifts produce a counter-gravitational effect, enabling the ITT to hover 0.5 to 1 meter above ground level, ensuring smooth traversal across urban streets, rugged terrain, and battlefield debris fields. The vehicle features gyro stabilization systems that continuously adjust thrust vectoring and altitude control, maintaining level positioning even on inclined or uneven surfaces. Additionally, shock-dampening inertial compensators reduce the impact of sudden velocity changes, improving crew stability and onboard equipment protection. Defensively, the ITT's exterior armor plating is designed to provide layered resistance against both kinetic and energy-based attacks. The angled hull design serves to deflect blaster fire and explosive shrapnel, reducing the likelihood of direct penetrative damage. The vehicle's outer durasteel plates are reinforced with a ferrocarbon lattice, increasing heat resistance and impact absorption, particularly against thermal-based weaponry and sustained blaster fire. To counteract ion-based attacks, which pose a risk to repulsor lift and electronic systems, the ITT incorporates triple-layered ionic shielding, that helps disperse EMP pulses and ion discharges before they can disable critical functions. Internally, the crew compartment layout is optimized for efficiency and rapid deployment. The pilot and gunner are positioned in the forward cockpit, with armored viewports and an array of optical sensors providing battlefield awareness. The cockpit features redundant manual and digital control systems, allowing the crew to maintain operational capability even in the event of sensor malfunctions or electrical disruptions. The troop compartment, located in the vehicle's midsection, is designed to accommodate up to 10 stormtroopers in full combat gear, with ergonomically structured seating and secure harness systems to stabilize personnel during rapid movement. Troop visibility is maintained via narrow, reinforced viewport slits, offering limited external awareness while minimizing potential weak points in the armor plating. The ITT's battlefield role and functionality dictate its Armored Personnel Carrier (APC) classification, focusing on urban suppression, checkpoint reinforcement, and troop insertion, rather than direct frontline engagement. Its moderate-speed repulsor lift propulsion system ensures it can keep pace with mechanized infantry and heavier armored columns, making it a versatile asset for coordinated Imperial operations. While not designed for high-speed reconnaissance, the ITT is capable of sustained movement in contested areas, providing troop support and mobile cover. Its structural durability and closed troop bay design make it resistant to insurgent ambush tactics, allowing it to traverse hostile territory with minimal vulnerability to small arms fire or environmental hazards. Armor integration follows a tiered reinforcement strategy, with thicker plating along the frontal glacis and side panels, while the rear compartment remains relatively less armored to preserve weight balance. Structural reinforcement ribs run along the internal frame, dispersing kinetic force impacts and preventing hull warping under heavy fire. Additionally, ceramic-based ablative coatings are applied to external plating to dissipate energy weapon impact points, reducing the risk of direct armor penetration. The cockpit and control systems feature a hybridized control interface, incorporating holographic tactical displays, manual input consoles, and direct link system synchronization with external Imperial command networks. The pilot's console provides real-time diagnostics on repulsor lift status, energy output, and sensor feeds, while the gunner's station integrates targeting overlays and automated threat assessment modules. The interface prioritizes efficiency and rapid response maneuvering, ensuring combat adaptability in high-intensity engagements. Access points and hatches are strategically placed to facilitate rapid deployment and emergency evacuation. The ITT features dual side access doors for personnel ingress and egress, as well as a rear deployment ramp, enabling quick disembarkation in active combat zones. The roof panel includes an emergency escape hatch, allowing for crew extraction in the event of catastrophic damage or rollover scenarios. These access points are reinforced with shock-sealed magnetic locks, preventing forced entry from hostile forces while maintaining pressurized integrity in hazardous environments. Cargo and storage capacity is integrated within the troop compartment, with dedicated storage bays for ammunition reserves, field medical kits, rations, and equipment modules. While not a dedicated supply transport, the ITT's internal layout allows for mission-adaptive storage, accommodating specialized loadouts based on operational requirements. The vehicle includes specialized equipment mounts and hardpoints, allowing for modular enhancements such as tactical sensor arrays, communications boosters, and additional armor plating. While the base model follows a standardized Imperial configuration, certain field modifications have introduced shield generators, reinforced side plating, and additional point defense turrets depending on mission-specific requirements. Stealth considerations are minimal, as the ITT is not designed for covert operations. However, heat dispersal baffles and low-signature repulsor lift generators help reduce its sensor footprint, making it less detectable at long-range scans. The exterior coating features a matte non-reflective finish, reducing glare and visual detectability in open terrain. Maintenance and repair accessibility is a key consideration in Imperial vehicle design, with modular paneling and external access ports allowing rapid servicing and system diagnostics. The engine bay and repulsor lift modules can be accessed via removable armor plating, enabling field technicians to perform repairs without requiring complete vehicle disassembly. Transportability and deployment are facilitated by Imperial dropships and cargo haulers, with the ITT's compact frame allowing for rapid aerial deployment. It can be airlifted into combat zones via external docking clamps, making it highly adaptable for planetary garrison reinforcement and fast response deployments. Compared to other Imperial ground vehicles, the ITT is more heavily armored than speeder-based transport craft, but less fortified than AT series walkers. It prioritizes troop protection and battlefield mobility, making it an essential component in urban pacification strategies. Its design ensures sustained operational presence in contested environments, allowing Imperial forces to maintain territorial control with rapid troop mobilization. From a tactical and strategic perspective, the ITT's structural design makes it a cornerstone of Imperial mechanized infantry doctrine, providing secured transport for ground forces while offering moderate defensive capabilities. Its reinforced chassis, adaptive armor layout, and repulsor lift propulsion system ensure that it remains a vital asset in both conventional warfare and counterinsurgency operations across the Galactic Empire's many occupied worlds. The K79-S80 Imperial Troop Transport, ITT, is designed for a crew of 4 individuals, each with specialized duties, ensuring the vehicle functions efficiently and effectively in a wide range of combat situations. The crew is composed of a pilot, gunner, commander, and potentially an engineer or support crew member, with each role contributing to the ITT's operational success and battlefield adaptability. This design ensures that the vehicle can perform its critical tasks, transporting troops, engaging targets, and providing versatile support, while maintaining a high level of operational efficiency. The pilot is the core of the ITT's mobility, responsible for its movement, positioning, and navigation through challenging environments. The vehicle relies on repulsor lift technology, which grants it the ability to hover and glide over different types of terrain, such as urban landscapes, mud, or rocky ground. The pilot must precisely control the repulsor lift systems to maintain optimal height, adjust speed, and ensure smooth maneuvering over uneven surfaces. This control is crucial, not only for avoiding obstacles, but also for keeping the vehicle steady in combat scenarios where quick maneuvers and sudden changes in direction are needed. The pilot is constantly adjusting the vehicle's altitude and speed, making them a key figure in battlefield mobility. Alongside the pilot, the gunner handles the offensive capabilities of the ITT. Positioned in a separate workstation equipped with advanced targeting systems and weapon controls, the gunner is responsible for engaging enemies during combat. The vehicle's weaponry includes turret-mounted blasters and point defense systems, which require precise targeting and firing accuracy. The gunner's role also includes managing defensive weapons that can neutralize incoming threats, such as anti-aircraft fire or enemy ground forces. These weapons are integrated into a sophisticated targeting system, which the gunner utilizes to lock onto targets both in close range and at longer distances. By analyzing real-time sensor data, the gunner can identify enemy positions, track moving targets, and adjust fire accordingly, ensuring the vehicle remains a formidable force on the battlefield. The gunnery role thus demands sharp focus and quick decision-making, particularly in high-pressure situations where the vehicle's survival and mission success depend on effective engagement of hostile forces. The commander holds a vital role in overseeing the strategic deployment and overall tactical decisions made during combat operations. The commander coordinates the crew, directing the pilot, gunner, and any other personnel present to ensure that all systems are utilized effectively in line with mission objectives. With access to an array of holographic battle displays and tactical AI assistance, the commander is able to monitor the battlefield in real time, processing intelligence data, and making rapid decisions. The commander's position also allows for communication with external forces, including higher command and other ground units, ensuring coordination across the wider battlefield. This role requires a broad understanding of the mission's objectives, the capability of the ITT, and the ability to adjust tactics on the fly based on changing battlefield conditions. While the pilot, gunner, and commander are integral to the ITT's primary functions, the vehicle can also accommodate a support crew member or engineer who provides technical oversight and maintenance. In high-intensity operations, having an onboard engineer can be crucial for ensuring the ITT remains operational even after taking damage. The engineer is responsible for monitoring the vehicle's systems, diagnosing issues, and performing emergency repairs if required. Given the complex nature of the ITT's propulsion, weaponry, and other internal systems, the engineer plays a crucial role in extending the vehicle's battlefield effectiveness. They are often the first line of defense against mechanical failures or malfunctions that could otherwise compromise the ITT's operational capabilities. The vehicle is designed with ergonomic considerations to ensure the crew can operate effectively under the stress of combat. The crew's stations are equipped with holographic interfaces, manual control panels, and sensor-linked targeting displays, allowing for rapid responses and precise coordination between the crew members. The pilot's seat, the gunner's console, and the commander's station are designed to ensure visibility and ease of access to critical controls. The design prioritizes combat efficiency, with each crew member positioned in a way that minimizes their exposure to enemy fire, while maximizing their ability to execute their responsibilities. This careful arrangement of crew stations ensures that all personnel can react swiftly and intuitively to battlefield conditions, whether it's maneuvering the ITT, engaging targets, or making strategic decisions. Safety and survival are also critical components of the crew's design. The ITT includes reinforced walls, blast-resistant panels, and shock-absorbing seating to protect the crew from enemy fire, explosive blasts, or internal malfunctions. The commander's seat, pilot's console, and gunner's position are all equipped with armor plating to reduce vulnerability to blaster fire and other forms of attack. Emergency ejection systems and blast doors are also in place to ensure that crew members can quickly exit the vehicle in the event of catastrophic failure or critical damage. Additionally, life support systems ensure that the crew remains comfortable and capable of operating the vehicle even in hazardous environments, whether it be through temperature regulation, air filtration systems, or environmental seals that protect them from external toxic atmospheres or extreme weather conditions. Through its well-organized crew structure, the K79-S80 ITT optimizes its performance in the field. By distributing responsibilities among the pilot, gunner, commander, and support crew, the vehicle ensures that each function is carried out effectively and that all crew members can focus on their specialized roles. The command and communication systems provide seamless integration, allowing for a coordinated response to battlefield threats and the efficient management of resources. The combined effort of the crew makes the ITT a highly versatile and capable vehicle, able to adapt to a variety of combat situations while maximizing its mobility, firepower, and battlefield presence. The K79-S80 Imperial Troop Transport, ITT, is specifically designed to carry a complement of personnel, including standard infantry, elite shock troopers, and support personnel. This vehicle's primary function is to transport and deploy troops efficiently, making it a key asset in a variety of combat operations. The transport can accommodate up to 40 to 50 troops, depending on their role and equipment, with its modular interior optimized for various battlefield scenarios. The ITT's design prioritizes swift troop deployment. To facilitate this, the vehicle is equipped with rear ramp access and side hatches that allow rapid boarding and disembarkation. These entry and exit points are designed to allow personnel to quickly enter or exit the vehicle in response to battlefield conditions. In combat situations, the rear ramp can be lowered in seconds, offering a wide opening for troops to storm out of the vehicle and engage the enemy or take cover. This rapid deployment mechanism is crucial for units engaged in high-intensity ground combat, where speed and efficiency are paramount. The side hatches are similarly designed for quick access, allowing troops to disembark from various angles if required, making it a versatile option in urban or dense terrain. The interior layout of the ITT is engineered to maximize space efficiency while ensuring that personnel are seated securely or have adequate support during transport. The passenger compartment is a standing room design with grab rails and secured footholds for stability during movement, as the vehicle can traverse uneven terrain or engage in rapid maneuvers. Troops are not seated in traditional crash seats, but are rather positioned in an arrangement that allows them to be fully geared and ready for deployment upon arrival. The space is organized into rows that ensure that all personnel can exit rapidly without obstructions. Although seating for each individual is minimal, the layout is optimized for functionality and efficiency, ensuring troops can stay prepared for immediate action upon arrival at their destination. The passenger compartment is equipped with environmental systems that allow it to adapt to different operational theaters. It is climate-controlled, ensuring that personnel remain comfortable in various environments, whether in extreme heat or cold. The vehicle is also pressurized and sealed against toxic atmospheres, allowing for safe deployment in environments that may be hazardous, such as battle zones with chemical contamination or deep space operations. Atmospheric filtration systems and oxygen supplies ensure that the internal environment remains breathable, even in areas where external air quality is compromised. This adaptation is crucial for extended missions where the vehicle may be operating in hostile or uninhabitable regions for prolonged periods. For the proper transport of equipment, the passenger area is equipped with various storage solutions. Weapons and gear are stored in modular racks and compartments built into the walls of the interior. These storage areas allow for the rapid stowing and retrieving of rifles, blasters, and other military equipment, enabling soldiers to stay ready at all times. The vehicle is also equipped with power recharge stations for energy-based weapons or personal equipment, ensuring that gear remains operational during extended deployments. This integration of storage and power systems ensures that troops are fully equipped for action as soon as they exit the vehicle. Troop deployment speed is a key feature of the ITT's design. The vehicle uses a hydraulic ramp system for quick troop disembarkation, with the ramp taking just a few seconds to lower, allowing personnel to hit the ground running. This speed is crucial for high-speed assaults or rapid insertion into combat zones. The vehicle can deploy a full squad within moments, and its internal systems ensure that all personnel are equipped and ready for immediate engagement. While the deployment time may vary depending on terrain and external factors, the ITT is designed for quick and efficient personnel delivery. The vehicle's deployed forces are often used in a variety of tactical roles, from shock troops performing direct assaults to support units providing logistical and mechanical assistance. The ITT is designed to be flexible, allowing it to carry a mix of infantry, engineers, or specialized forces depending on the mission. This versatility makes it an essential asset for mechanized infantry operations, where the combination of troop mobility and battlefield presence is vital for success. Passenger protection is a critical component of the ITT's design. The interior is lined with reinforced bulkheads and blast-resistant walls, offering protection against enemy fire and explosive ordnance. The vehicle is equipped with inertial dampeners, ensuring that the jarring effects of sudden maneuvers or rough terrain do not harm the personnel inside. In the event of a catastrophic failure or direct hit, the vehicle features emergency escape mechanisms, such as rapid deployment escape hatches and reinforced bulkhead seals, which protect the occupants from environmental hazards or enemy fire. Communication and coordination between the crew and passengers are facilitated by an integrated internal comm system, which links the passengers with the vehicle's command and external forces. Troops can communicate directly with the crew to adjust deployment strategies, request support, or report mission status. The vehicle also integrates holographic tactical displays and real-time battlefield data uplinks, which allow passengers to monitor the situation outside the vehicle and adapt their strategies accordingly. Medical and survival systems are integrated to ensure the well-being of troops during extended operations. The vehicle includes a basic medic station with automed systems, where medpacks and emergency treatments can be administered to wounded personnel during transit. For particularly severe injuries, the ITT can be equipped with emergency stasis pods that temporarily stabilize critically wounded soldiers until they can be evacuated or treated at a more advanced facility. While the ITT is optimized for rapid deployment and combat readiness, its passenger compartment is also designed for long-term operational missions. Basic amenities such as ration storage, hydration dispensers, and waste disposal units are included to support personnel during extended missions. These features ensure that troops can remain operational even in prolonged engagements, enhancing the vehicle's effectiveness as a long-range transport unit. In comparison to other vehicles within the Star Wars universe, the K79-S80 stands out for its combination of speed, armor, and deployment flexibility. While other transports may prioritize either speed or protection, the ITT strikes a balance, making it a highly adaptable solution for a variety of mission types. It offers superior deployment speed and capacity compared to many similar vehicles, and its design makes it highly effective in both urban environments and open battlefield scenarios. The tactical implications of the ITT's passenger capacity and deployment systems are significant. Its ability to carry a large number of troops and deploy them quickly gives it a strategic advantage in combat, allowing forces to maintain momentum, reinforce positions, or disrupt enemy lines rapidly. The vehicle's design not only facilitates troop transport, but also enhances overall battlefield coordination and effectiveness, ensuring that personnel are always ready to deploy when needed. This adaptability makes the ITT an indispensable asset in a wide range of combat operations, contributing to its value as a key component of Imperial forces. The production of the K79-S80 Imperial Troop Transport, ITT, was a sophisticated process involving several key players within the galactic military-industrial complex. The primary manufacturer responsible for the vehicle's design and mass production was Quat Drive Yards, a major player in producing military-grade hardware for the Galactic Empire. Known for its extensive capabilities in shipbuilding and vehicle construction, Quat Drive Yards also spearheaded the production of ground-based military vehicles. Other contributors may have included Rothana Heavy Engineering, known for creating advanced combat vehicles for the Republic, and smaller specialized contractors who provided key components such as Bactoid Combat Automata, which was responsible for some of the automated systems integrated into the ITT. Factory and shipyard locations for the ITT's production were spread across several key industrialized planets and highly secured military shipyards. The vehicle's mass production likely occurred on industrial hubs like Kuat, where large-scale vehicle manufacturing was optimized by vast automated systems and assembly lines. In addition, specialized factories on military shipyards, such as those on Korulag or Fondor, would have been used to assemble the ITT in high-security facilities. These shipyards possessed the infrastructure to produce complex vehicles like the ITT, leveraging automated droid manufacturing systems and advanced assembly lines to maintain high throughput while adhering to strict military requirements for quality and precision. Given the sophistication of the vehicle and its strategic importance, the cost per unit of the ITT would have been relatively high. However, the design and production processes were optimized to balance performance and mass production efficiency. Unlike high-end custom vehicles that incorporated rare or specialized materials, the ITT utilized composite alloys and reinforced durasteel, which, while expensive compared to civilian materials, were abundant and affordable for large-scale production. The use of readily available materials and the vehicle's modular design meant it could be mass-produced in relatively short order, without straining the Empire's resources excessively. The unit cost would have been much lower than that of specialized equipment like AT-ATS, but it would still represent a significant investment for the Empire. The materials required for the ITT's production were varied. The frame of the vehicle was primarily constructed from reinforced durasteel, providing strength and durability against blaster fire and other battlefield hazards. Composite alloys were used for weight reduction in certain parts of the vehicle, ensuring that it remained highly mobile and capable of quick deployment without compromising structural integrity. More advanced energy-resistant plating was integrated into areas likely to be exposed to heavy fire or explosive damage, offering critical protection to both the vehicle and its crew. The materials needed for these components, though not exceedingly rare, still required careful management to ensure that sufficient quantities were available for mass production. Polymer composites were used in non-essential areas to save weight and reduce the overall production cost. Given the war effort and ongoing demand for military hardware, some raw materials, such as high-grade durasteel, may have been in short supply, leading to production delays and political maneuvering over access to these resources. The manufacturing process for the ITT was a highly streamlined affair. At Quat Drive Yards and other facilities, the vehicle was largely mass-produced, using automated systems for initial assembly. Droids were heavily involved in the assembly process, ensuring precision and speed while maintaining a high level of quality control. While some components of the vehicle required manual assembly and testing by skilled technicians, the core of the production process was driven by automated fabrication systems. This included the assembly of the internal passenger compartment, integration of the propulsion systems, and installation of various environmental systems. Final assembly was completed in military foundries where technicians would perform quality control, inspect the vehicle for flaws, and conduct initial field tests to ensure readiness for deployment. Depending on the scale of the factory, Producing a single ITT could take anywhere from a few weeks to a couple of months. However, mass production facilities were capable of scaling production and churning out hundreds of units in a short time, depending on military demand. The modular design of the ITT played a key role in its adaptability and production efficiency. The vehicle's core structure remained constant, but the various subsystems and internal configurations could be easily swapped out depending on the mission requirements. This included varying the armament loadouts, adding extra armor for specific roles, or adjusting the seating capacity to accommodate different types of personnel. This modular approach allowed quad drive yards to produce different variants of the ITT for specific roles, whether for elite shock troops, standard infantry, or mechanized support units. Variants were likely produced alongside the base model in the same production lines, reducing downtime and maximizing efficiency during wartime. The logistical challenges associated with the ITT's production were significant, as with any large-scale military manufacturing effort. The Empire's war economy often strained resources, making certain materials difficult to procure. For instance, rare alloys for reinforced armor plating and advanced composite materials for the vehicle's frame were sometimes in limited supply. This meant that production lines often had to adjust to these shortages, leading to delays or suboptimal substitutions in materials. Additionally, the Empire's policy of centralized production control meant that certain factories and shipyards were subject to political interference or sabotage, especially during times of galactic unrest or rebellion. These challenges sometimes led to slowdowns in production or forced adjustments in the timeline, making logistics a constant hurdle in meeting military demands. Once the ITTs were completed, they were delivered to military units through highly specialized transport ships designed to carry heavy equipment to frontline deployment zones. Once the vehicles arrived at strategic locations, they were integrated into the Imperial Force's mechanized infantry divisions, ready to be rapidly deployed in combat. In many cases, ITTs were produced on remote frontline assembly sites closer to conflict zones, ensuring that the Empire's forces had ready access to the vehicles when needed. This also allowed for continuous production and replacement of lost or damaged vehicles, ensuring the Empire could maintain a strong and effective presence on the battlefield. The production speed of the ITT was significant, especially given the scale of the conflict and the need for rapid deployment. However, the vehicle's mass production was not without its limitations. While it was designed to be efficient and quick to produce, the complexity of integrating multiple systems, armor, propulsion, environmental controls, meant that some specialized components, like advanced propulsion systems or weapon mounts, required more precise assembly, slowing down overall production. Despite these bottlenecks, production lines were capable of scaling up significantly during wartime to meet demand. The political and military influence on ITT production was substantial. As the vehicle was produced for the Empire, government contracts determined the scale and pace of its manufacturing. During periods of intense conflict, like the Galactic Civil War, the demand for such vehicles surged, leading to the prioritization of their production. Political considerations often influenced whether the ITT would be produced in secret, or whether its use would be restricted to elite units. Certain factions within the Empire may have pushed for specialized versions of the vehicle to be produced for high-profile missions, while others may have opted for mass deployment. When comparing the production efficiency of the ITT to other similar vehicles, it is clear that the transport was a relatively cost-effective solution for the Empire's needs. While other vehicles, such as ATATs, were significantly more expensive and resource-intensive, the ITT's modularity and use of standard military-grade materials allowed it to be produced at a much lower cost. This made it a highly viable option for large-scale deployment, and its mass production capabilities made it essential for rapid reinforcements and troop movements. Once production ceased, many of the old ITT units were repurposed for secondary uses. Some were sold to mercenary groups or used by various factions as cheap, durable transports. Others were likely scrapped for parts or adapted into civilian-use vehicles in the aftermath of the Empire's downfall. Some of the more robust designs may have been modified for continued service, though they were no longer part of the Empire's core military assets. The strategic impact of the ITT's production was profound. Its ability to be mass-produced allowed the Empire to rapidly deploy large numbers of troops, making it a cornerstone of their ground assault operations. The vehicle's affordability, paired with its adaptability, ensured that it played a significant role in the Empire's ability to maintain control over vast swaths of territory during the Galactic Civil War. However, the cost and resource demands of production also meant that the Empire's overall supply chain had to be carefully managed to avoid disrupting other aspects of its war machine. The Imperial Troop Transport, ITT, produced by Ubrikian Industries, was one of the most widely used vehicles in the Imperial Army during the Galactic Civil War. Its initial design focused on mobility and transportation capabilities, making it ideal for dropping soldiers into combat zones or quickly deploying forces to maintain Imperial control over distant planets. The ITT could carry up to 40 stormtroopers, and its design was meant for both rapid deployment and defensive capabilities, with blaster turrets mounted on its exterior to provide covering fire. Around 15 BBY, an event unfolded on a remote wild space planet that would eventually intertwine the fates of the Empire and one of its most dangerous future adversaries. The Empire, in its relentless search for threats to its dominance, had deployed 2 squads of Imperial clone troopers to investigate reports of a mysterious alien presence. These troopers disembarked from an ITT in a dense jungle environment, armed and ready for what they believed would be a routine search and destroy mission. Unbeknownst to the troopers, their quarry was Mithrao Nurodo, the Chiss who would later become known as Grand Admiral Thrawn. At this point, Thrawn had not yet gained the trust of the Empire, and he was operating in secrecy, determined to join their ranks and bring his genius tactics to their cause. Disguised in the stolen armor of one of the clone troopers, he infiltrated the Imperial Star Destroyer Strikefast, a key vessel in the Imperial Navy. The clone troopers, unaware of Thrawn's true identity, scoured the jungle for hours, failing to find him. The clever Chiss had already outsmarted them, slipping away undetected and beginning his plan to rise within the Empire. This marked the beginning of Thrawn's ascent, a journey that would eventually lead him to become one of the Empire's most feared and respected military minds. The Imperial Troop Transport thus played an indirect role in Thrawn's recruitment by the Empire, unknowingly setting the stage for his future contributions. Years later, during the early days of the Galactic Civil War, the Empire once again utilized the ITT to track down a group of rebels on the planet Gorse. The rebels, including the Twilight Starship crew, Hera Syndulla, Kanan Jarrus, and Skelly, had just attempted to assassinate Imperial Count Demetrius Vidian, a high-ranking officer responsible for Imperial construction projects across the galaxy. Syndulla and her crew, known for their resourcefulness and daring, had been fleeing across the galaxy after a failed attack, and the Empire was determined to capture them. A fleet of Imperial troop transports was dispatched to the surface of Gorse, with the goal of tracking down the rebel crew and neutralizing the threat. As the ITTs descended upon the planet's surface, they began to systematically search for their quarry, deploying soldiers and scout teams across the planet's various terrains. The troop transports effectively cornered the rebels, but Syndulla and her crew weren't easily caught. Using a combination of explosives, highly skilled evasive maneuvers, and their knowledge of the planet's geography, the rebels managed to narrowly escape the Imperial forces. Syndulla's daring piloting and strategic thinking played a key role in the escape, allowing them to make a quick getaway in their ship. Despite the Empire's superior numbers and firepower, the rebels' ability to outsmart and outmaneuver their opponents resulted in a rare victory for the Rebel Alliance. These incidents, among others, highlighted the strength and weaknesses of the Imperial troop transport. While it was effective in transporting soldiers and providing support in planetary assaults, it was still vulnerable to guerrilla tactics and quick-thinking rebels. The Empire's reliance on the ITT would continue throughout the war, but its use also highlighted the limitations of the Empire's otherwise formidable military forces. In 3272 LY, an Imperial unit stationed on the planet Lothal employed an Imperial Troop Transport, ITT, for a seemingly mundane mission, transporting a valuable cargo of Mayluran fruit. This exotic fruit, known for its sweet and rare flavor, was purchased from the nearby city of Kothal. The Imperial forces were using the fruit as part of their efforts to establish control over the local population, leveraging the distribution of such goods to strengthen their presence on the planet. However, the The young Ezra Bridger, a skilled street urchin who had spent most of his life surviving by scavenging the streets of Lothal, was always on the lookout for ways to get by. His instincts led him to spot the ITT convoy as it passed through the city, the fruit shining in its crates, too tempting to resist. Ezra, who had already developed a knack for sneaking around, decided to make a move. His goal was simple: steal some of the Maelorans. He stealthily approached the Imperial troop transport, intent on getting a taste of the precious fruit. However, his plan quickly unraveled when he was spotted by a stormtrooper while inspecting one of the crates. The troopers immediately raised the alarm, alerting the rest of the unit to his presence. Ezra, realizing the danger, quickly fled the scene, but not before his attempt to swipe the fruit was interrupted. His boldness, while daring, would set in motion a chain of events that would escalate tensions on Lothal. Shortly after the encounter with Ezra, Supply Officer Yogar Leist, a key figure in the local Imperial command, decided to take more direct action against the local resistance on Lothal. As part of his efforts to punish the rebellious farmers and increase Imperial dominance in the region, Leista ordered an assault on the farm of Morad Sumar, a well-known local farmer sympathetic to the Rebel Alliance. Using 3 ITTs, Leista led a strike team to the farm, intending to capture Sumar and his family. The stormtroopers stormed the farm and overwhelmed the defenders. Morad Sumar, his wife, and an Aqualish employee were swiftly taken prisoner and loaded into one of the Imperial troop transports, which was designed for both combat and transport duties. The ITT, now carrying the captives, began making its way back to an Imperial holding facility, where they would be interrogated. Yet Ezra Bridger, who had earlier been spotted by the troopers, was not one to let such injustices stand. Fueled by a newfound sense of purpose and a growing sense of rebellion, Ezra decided to rescue the captured family. With his partner, Garazeb Zeb Aurelius, a former Lasat soldier with a strong sense of justice, Ezra mounted a daring rescue operation. The duo launched an attack on the convoy, hoping to free the prisoners before they were taken too far. They managed to infiltrate the Imperial convoy, taking out a few stormtroopers along the way and causing enough distraction to create an opening for their escape. The two rebels fought their way toward the ITT that was carrying the Sumar family, and with quick thinking and well-timed maneuvers, they successfully liberated the prisoners, freeing them from the grip of the Empire. This mission would mark a turning point for Ezra Bridger, strengthening his resolve to resist the Empire and align with the Rebel Alliance, which was growing in strength and influence across the galaxy. It also highlighted the dual nature of the Imperial troop transport. Though effective in maintaining order and asserting control over rebellious populations, the ITTs were also vulnerable to guerrilla tactics and could be used against the Empire by those brave enough to stand up to tyranny. In the aftermath, Ezra and Zeb's daring rescue became part of the growing legend of the Spectres, a rebel cell that would go on to play a pivotal role in the Rebel Alliance's efforts to combat the Empire and fight for the freedom of the galaxy. In 3 ABY, the refined version of the Imperial Troop Transport, ITT, was used in an operation on Tatooine. The ITT was tasked with transporting stolen weapons and a contingent of stormtroopers, but the transport came under attack when it was intercepted by K. Vess, a skilled individual who had become notorious for disrupting Imperial operations. The transport's mission, meant to deliver a supply of weapons to an Imperial outpost, ended in failure, with the interceptors taking control of the cargo and foiling the Imperial plans. The revised design of the ITT, a more robust version of the original, had been designed for both transportation and support in combat situations, but it was ultimately ineffective against the targeted assault. The Mandalorians, known for their combat expertise and resourcefulness, also had a version of the ITT used during various campaigns, including some covert operations. Mandalorian stormtroopers, typically a part of specialized units within the Empire, were seen disembarking from an ITT in 9 ABY during a mission on Tatooine. This particular transport lacked the traditional front turrets, a modification that may have been intended to reduce its profile and make it less conspicuous. However, despite the modification, the lack of firepower left the crew and troops vulnerable to potential ambushes, especially in the desert environment where the enemy could hide behind dunes or structures. In 9 ABY, the refined ITT model saw further use during the Battle of Jakku, a pivotal confrontation that marked the final stand of the Empire against the New Republic. The battle took place after the destruction of the second Death Star and the fall of the Emperor, with the Imperial fleet fighting for its survival on the distant desert world. In this final battle, the Imperial troop transport was used to deploy stormtroopers and carry out infantry missions across the harsh terrain of Jakku, attempting to suppress Republic forces in a desperate effort to regain control. However, the battle ultimately ended in the Empire's defeat, and the Battle of Jakku cemented the New Republic's victory in the war. The remnants of the Imperial forces scattered, leaving behind the wreckage of their once unstoppable war machine. Years later, Moff Gideon and his Imperial remnant would utilize the refined ITT model for their operations in 9 ABY, long after the Empire's collapse. The Moff's forces, stationed on Navarro, deployed the transports to confront Din Djarin, the Mandalorian bounty hunter, and his allies as they fought against the remnants of the Imperial regime. Alongside the Mandalorian stormtroopers, Moff Gideon's forces also used other Imperial vehicles to enhance their combat capabilities. One notable vehicle in their arsenal was the Trexler 906 Armored Marauder, an upgrade to the ITT that was designed for more intense combat scenarios. The Marauder, with better armor and weaponry, was kept within the Navarro base and provided vital support in the struggle to subdue the rebels and bounty hunters who had aligned themselves against the Empire. This series of events highlights the evolution of the ITT over the years, from its original role as a transport vehicle to its eventual adaptation into a combat unit, used in critical operations by both the Empire and its remnants. While the original design of the ITT had limitations, the adaptations and strategic deployments in later years ensured its relevance in the fight to maintain Imperial control over the galaxy, even as the forces of rebellion continued to challenge its authority. In 0 ABY, the Empire deployed the Imperial Troop Transport, ITT, under the command of Imperial Security Bureau, ISB, Agent Mar Berez, in a failed attempt to capture Rebel Alliance recruits. Berez's operation on Tatooine was part of the Empire's larger campaign to root out and destroy the Rebel Alliance by targeting their personnel. Despite their efforts, the recruits managed to escape, slipping through the clutches of Berez's forces and evading the traps set by the Imperial transporters. This failure added another layer of frustration to the ISB's already challenging mission of curbing the rebel uprising, highlighting the relentless nature of the rebel forces and their ability to evade Imperial pursuit. In addition to patrol duties, the rebel transporter RTT and its variants saw extensive action in search and destroy missions. A notable example of this was during the search for the stolen Death Star plans. The Empire launched a concerted operation on Tatooine, using multiple transporters to scour the vast desert landscape. This operation led to a violent encounter with a band of Jawas, who were suspected of harboring the droids carrying the Death Star plans. The Imperial troopers detained the Jawas, interrogating them ruthlessly. However, their efforts ultimately culminated in a massacre when they killed the Jawas and destroyed their sandcrawler, using the transporter's cannon, leaving a scorched desert wasteland in the wake of the brutal operation. The search for the plans proved ultimately unsuccessful, as the droids, R2-D2 and C-3PO, were already well on their way to delivering the plans to the Rebel Alliance, setting the stage for the galactic civil war to reach new heights. Several transporters were later utilized by Orman Tag on Tatooine in the aftermath of the tragic events surrounding the destruction of the Death Star. Tag, a prominent Imperial officer, had his own transporters deployed during a test of his brother's dangerous invention, the Omega Frost. This experiment, which had far-reaching implications for the Empire's military capabilities, saw the transporters used for both defensive and logistical purposes as they moved across the harsh desert terrain. The transporters proved valuable during this testing phase, despite the tensions surrounding the failure of the Omega Frost, which, much like previous Imperial projects, met a tragic end. In the years following the Battle of Endor, the transporters and their variants also participated in the Imperial Civil War that erupted around 10 ABY after the Death Star II's destruction. Imperial factions, fractured and disorganized, used the transporters to shuttle troops across the war-torn streets of Coruscant as they clashed in the heart of the former Empire. These fierce skirmishes marked the chaos of the period, where different factions of Imperials fought for dominance in the wake of the Emperor's fall. The transporters, once symbols of the Empire's might, became workhorses of the Imperial Civil War, ferrying troops to battlefields across the galaxy. The transporter's role in these key moments underscores its importance as a versatile vehicle in the Empire's arsenal, equally capable of handling patrol duties, search operations, and combat roles. From tracking the stolen Death Star plans on Tatooine to shuttling troops during the Imperial Civil War, the ITT's legacy is intricately tied to the ebb and flow of the Empire's fortunes. The Trexler 906 Armored Marauder was a heavily armored, repulsor lift-driven transport designed as a combat-ready variant of the K79-S80 Imperial troop transport. Manufactured by Trexler, this boxy gray craft was built for missions requiring enhanced durability and firepower, often deployed in high-risk environments where standard troop transports would not suffice. Though the Trexler Marauder was produced in limited numbers, it was a coveted asset for Imperial forces due to its robust build and advanced weaponry. The Trexler Marauder's construction made it highly resistant to blaster fire, with thicker plating compared to the K79-S80, allowing it to withstand considerable damage on the battlefield. Its repulsor lifts enabled it to levitate above the ground, making it a versatile transport that could move across rough terrain with ease. The craft housed 3 crew members, 2 pilots and 1 gunner, along with space for a number of troopers. Its sleek design included blocky, open viewports for the pilots at the front and a dorsal twin laser turret operated by the gunner at the rear. This turret could rotate 360 degrees, targeting both air and ground-based enemies with pinpoint accuracy, enhanced by a starship-like targeting computer. Additionally, the Marauder was armed with forward laser guns and cannons to provide offensive capabilities during combat situations. One of the Marauder's most notable appearances came during the New Republic era, when an Imperial unit led by Moff Gideon used it as part of his Imperial remnant forces on the planet Navarro. The vehicle became the focus of a high-stakes escape and pursuit after Greef Karga, Cara Cynthia Dune, and a Mithril rebel managed to steal it from an Imperial base under attack. The trio hijacked the Marauder, with Dune piloting the craft, and successfully evaded capture by Imperial forces. As the Marauder took flight, the crew quickly found themselves pursued by Imperial scout troopers on 74Z speeder bikes, leading to a fierce chase through the ravines surrounding the Imperial facility. The Marauder's superior firepower proved crucial in escaping the pursuit. Karga, manning the gunner's position, used the dual laser turret to destroy several bikes, including crashing one into a cliff face, while another bike was obliterated by direct fire. A third bike was destroyed in close quarters, and Karga swiftly neutralized a final trooper who attempted to attach explosives to the transport. The Marauder's escape was far from over. 4 Outland TIE fighters soon appeared, swooping in from above to engage the transport in the skies. Karga fired the twin laser turret, severely damaging one fighter and sending it crashing to the ground. However, the Marauder's luck ran out when the burning cockpit of the TIE fighter collided with the Marauder, knocking out the turret and leaving Karga temporarily incapacitated. Just as the Marauder was being harried by the remaining TIE fighters, Din Djarin, aboard the Razor Crest, arrived on the scene, using his ship's weapons to eliminate the remaining Imperial threat. The Trexler 906 Armored Marauder's appearance in this encounter demonstrated its impressive resilience and combat prowess. Despite the chaos surrounding its theft, the Marauder's powerful armament and durable design allowed its new owners to fight back against relentless Imperial forces. However, its final fate remains uncertain, as it was last seen being used by the remnant forces of Gideon in a skirmish with the Mandalorian bounty hunter Din Djarin. Though now a rare commodity, the Trexler Marauder's unique features and history made it a sought-after vehicle, with significant value in the black market. The Marauder's role in this high-octane escape only solidified its reputation as one of the Empire's more fearsome transport variants, ideal for both troop deployment and combat operations in hostile environments.